And welcome back, and I hope that everyone is having an excellent day. You can see we've got our supervisor in our shop today. And if you're following the videos in series, the last video we did a successful startup and checked fluids, did some scans, and one item that kept coming back on the scan was the short runner valve, as the Dodge calls it, in the back of the intake. And it was an item that we thought would more than likely rear its head based on the way this actuator was fitting on the back of the new intake. If you remember, it would fit, but you had to kind of tweak it down quite a bit to get the screw holes to line up to get it to go into place versus how it looked on the factory intake. And in that last video, we made a comment that we were going to order another intake, and that intake is here. But this is not an OEM intake, because it was OEM intakes are still hard to get hold of. They're still on back order. So we ordered this one from the Amazon, just like we ordered this one, but this one was from LKQ. Unfortunately, I was hoping that this intake would be different than that intake, and although this one's a bit darker in color and a bit more shiny, this one is not. However, from all intents and purposes, it comes with the exact same colored gaskets on it. I think this is literally the same part being sold by two different manufacturers on the same website, because when we went to fit this, it fit the same way it did on this replacement intake, where it was kind of cocked up like this, and you had to kind of really just kind of pull it down and hold it to get the screw holes, bolt holes, to line up so you can bolt it in. So it didn't look encouraging, at least from all intents and purposes. It looked like if we went through the trouble of putting this one on the motor, that we were going to have the same fault with this SRV. So we got to kind of looking into the operation of this SRV, and we do have a replacement, aftermarket replacement of this coming in, because again, this is also hard to get a hold of. It's not here yet. Hopefully it'll be here today. But we got to looking at the operation of this solenoid, as it's called, and it uses a PWM signal that's generated from here, sends back to the PCM and tells the PCM the position that this is in. And the fault that it is throwing is this P2017 short runner valve position sensor circuit high. So it's seeing a higher than expected feedback from this module as far as its position. Now, I took this module apart, and we'll do the same thing here yesterday, just to kind of look at it. And as far as the motor is concerned, from what I can see, it just drives the motor with power, either forward or reverse. And then it looks like it uses a current spike to determine that the motor has reached its end of travel, because there's no other mechanism on the gearing of this or the motor of this that seems to have any kind of feedback circuit to the circuitry on the inside to say, hey, I've reached end of travel. So it looks like the power feed that comes in hits the motor, runs it until it physically gets stopped by the limit travel of the runner, or the shaft that runs the plenum, the runners inside the intake. And then when that happens, the current draw for the motor spikes. The module, or the circuit board module that you'll see inside of here, then picks up on that and sends a feedback to the PCM via pulse width modulation to basically tell the PCM the position it's in. So where I'm getting at with this is that while looking at this yesterday, and if you remember, when we went to first put this in, it was kind of cocked like this. And I'll show you when we get this apart, but we can actually kind of manually move the thumb screw that's in here, that's attached to the motor, and actuate and move the position of this stub shaft here. And that will get it to better line up with the intake. Because again, it doesn't look like it actually looks at the exact position of this. It more just checks the current draw of the motor to then determine if it's at end of travel. So if that's the case, we may be able to kind of pop this cover off. I know we can pop the cover off, but we can manipulate this to get this to line up better with the shaft that's in here, so we don't have to kind of pull it down as hard, and then kind of button it all back together. We can temporarily hook just this SRV up to the wiring harness and then actuate it with a scan tool, open and close the SRV runners inside this intake, and see if it'll set this same fault code we're getting here. And if it doesn't, then we should be good to kind of put this back together. Now, it's kind of a, I don't know if you want to call it hack way of doing it, but it's the only way I can think of to kind of compensate for the fact that these runners do move. And I can let you hear that here. Like, for instance, if I just grab the little stub shaft that's there, you'll hear this. You'll hear those runners move. So they do move, and they do move freely. I just think the travel on this one is slightly different than an OEM intake. Now, the amount of travel between the OEM intake, what this one does as far as left and right, is almost identical to this one. So I don't really want to fault the intake per se and say that it's out of spec. I'm wondering if this motor, after, just because this is the actuator, the original 2012 actuator, I'm just wondering, after years and years and years of it, actuating this intake here, it's just kind of gotten set for the tolerances of this intake versus putting this one on a new one. Anyway, that's just the kind of thought behind it. It's at least something that we can do to test to see if we can get rid of this fault. And like I said, I've got another one of these coming. It's just not here yet, but I figured this would kind of be something good for us to kind of peel into and try. So what I'm going to do is I'm going to pause you, bring you back, and then what we're going to do is we're just going to pop these metal clips off, separate this clamshell, and we'll see the internals, and you'll see where I was talking about, where we can kind of manipulate where this stub shaft is facing as far as direction, and we can get it to better line up with the shaft in this intake and kind of get it to bolt on a lot straighter and a lot easier. So let me do that, and I'll bring you back. One moment. And welcome back. So I'm just going to use a small flat blade here and get underneath these clamps. Just kind of pop them out of position, just like that. Because I've been reading the reviews on these intakes, these aftermarket intakes, and a lot of people say they work. They're not complaining about this particular problem. So again, I'm wondering if there isn't just something off with this actuator. Now I'm just working to separate the two pieces like I did yesterday. There's a weather seal. There's a guide pin here on this side that goes through, and I believe it's another one around one of these corners. Yeah, one here, and it looks like another one here. Once you can kind of get underneath this and get it started to separate, then the rest of it will kind of follow. There we go. I'm just being careful not to stab that weather seal that runs around the side of this. If this fixes the issue, yay, great. And hopefully it helps out anybody else that may be using one of these intakes and then getting this particular fault. And I don't really want to have to put the old factory intake back on here because it's pretty cruddy. Again, not saying that it wouldn't work, but there we go. So you can see there's our control circuitry. All it has is 2 power wires that come off and hit this motor here. And that is the only electrical connection between this motor and this gearbox or this gear set and here. And I don't see anything like any electrical contacts that would sweep. You know, there's no electrical contacts on this gear. There's no like opto isolators, anything of that nature that would give any kind of feedback to this control board here of the position of the motor. That's why I was saying earlier, I think it's using just pure current draw of this motor to determine that it's reached a stop, kind of like what the actuators do for the HVAC box. Like when you're switching, at least in a Dodge, when you're switching between heat and cold and floor and dash vents or floor and defrost and things of that nature, a lot of those actuators are only 2-wire actuators. So they're either drive them, you know, forward or reverse. And the PCM or the body control module, I think in that case, just relies on a current pulse, a current spike to realize that the motor's reached end of travel. Yeah. Okay. So this is what we can do. So this, again, that's our logic side of it. And this generates a PWM signal and sends back to the PCM to tell the PCM the position of this unit here. So I think what's happening when we were doing this before and we kind of forcibly pulled down on this to get this to mount into the intake, it was binding this actuator, and that binding caused too much of a current spike, and it reported back basically a value to the PCM and says, whoa, you know, I'm completely out of position here. So this is what I was doing early. This is what I was doing yesterday, is that we can grab the motor here and just kind of spin it by hand and change the location of where this points. Put that gear back in. And I may even get a little bit of lube and just kind of put inside this screw gear here while we got it open. But what we can do is just keep turning this until we get this in a position where it lines up with the shaft on that intake, and then we can kind of reassemble it, go in there, toggle this with our scan tool, and see if we can get this position circuit high error code to come back or not. So let me do that. Let me again, I'm just going to continue to rotate this until this lines up, and I'll bring you back and show you what it looks like. One moment. And welcome back. So you can see I put just a little bit of grease on that gear because it was pretty dry. Like I said, they had a little bit of grease. It looks like it kind of ended up on the circuit board there. Kind of just after years and years and years of heat cycles or whatever, probably just came off the gear. Like I said, not too much, just a little bit. But we did rotate this motor around, and as you can see now, we've got that slot or that keyway lined up with the little stub shaft in the intake pretty well, and you can see that all of our bowl holes line up, and it takes like pretty much no effort. It'll sit where it needs to sit as far as being bolted in place. So what we're going to do next is just reassemble this, get it bolted back at the end of our intake temporarily just kind of place the intake up in the vehicle and just hook up this SRV actuator, and then we'll test it with a scan tool and see if we can get A, to actuate without an issue, and B, actuate without throwing this code again. And the reason why I'm kind of speculating that it's just using a current draw of the motor to realize it's reached end of travel is that yesterday I hooked up just this module without being attached to the intake and actuated it with a scan tool. And the interesting thing is that that's not a home position that I can see. In other words, without this being attached to the intake and kind of having something that would physically stop it, it would actuate it and then return, but it wouldn't return to that exact position. It's like it would advance it and then kind of roll itself back. And I think the issue was that since it didn't have that resistance, that hard stop, it never saw the current spike of the motor, and the PCM would just kind of stop and then just move it back to what it thought was its original position, but it would never be like this position. So in other words, if we took this actuator and plugged it in right now and actuated this open and then close and then checked it, that would be in a different spot. So what we're going to do, I'm going to get you down here, just kind of show you the reassembly of this. It's not terrible. You can see that's the electrical connections for our motor that goes onto the motor tabs there. But there's some alignment tabs. You can see them here, here, and here. So there's 3 of them on this case half, and you just reassemble your clamshell. There we go. And then we could just take our clips without dropping them, hopefully. Just get them started on one side and then just push them forward and they'll clip back in. So let me go ahead and get this clipped back together. We're going to get it mounted back on the back of this intake, and then we'll get it up in the vehicle, get it temporarily wired, and do some more testing. So one moment. And welcome back. So you can see we just have our intake. It's just placed up there. We really only wanted the SRV solenoid connected in. So got our key on, got you plugged into the got the scan tool plugged in here, I should say. We're just going to local diagnose. American, Dodge, yes. Now when we scan the PCM and look at trouble codes here, you're going to see quite a few, because obviously we've got a lot of sensors disconnected, throttle body and such, which it's going to be kind of unhappy about. Yes, there's the right vehicle. I'm just going to go on the system list because we know we want the PCM. And read fault codes. There's going to be a couple in there. Yeah, intake air temperature sensor, generator field circuit for the alternator, because we've got the alternator unplugged, manifold. Yep, electrical, throttle body, throttle body, throttle body. Okay, so that's all pretty much normal. That's what we expect. But if we go into actuation test here on the side, yes, understood. Some of it requires the engine to work, but not for this particular test. So intake manifold, SRV, short runner valve, solenoid control state. And all I'm going to do is going to toggle this to open, and open between open and closed, and we're just going to listen as well. Okay. Didn't hear anything. Now I'm going to toggle it to closed. Okay, also not hearing anything come out of the intake. And all I'm going to do, I'm just going to continue to toggle between open and closed here. Yeah, I may have heard it. I may have just kind of faintly heard the intake there for a second. Yeah, I can kind of hear it going dee 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 a little bit. I don't think the camera's picking it up. But now that we've done that a couple of times, I don't think the data stream's going to tell us much, but so let's look at the output control state and the PWM feedback. Okay, so right now it says we're closed, so control state de-energized. I'm not seeing the output control state change much or the PWM feedback. Yeah, not seeing much come back on the actuation test as far as the data stream. But let's scan for DTCs again. See, yeah, see, short runner valve control circuit. So yeah, we immediately got back that right there, which is not what we wanted to see. Yeah, so it's having a P2008, and there it is right there. Intake manifold runner position sensor circuit high bank 1. So it's still having a problem with the position. So, I mean, at this point, we tried it. It didn't work. It could just be a broken SRV actuator at this point, or we could have a broken wire, or it could just be that the runners in this intake are just not set up correctly for that thing to actuate correctly. What we're going to have to do is I'm going to have to wait for that other actuator to come in and put that on this same intake and just see if it makes any difference at all. Because what I can do, I can shoot. There actually is a, hold on, there's one more test we can do to verify here. Because you can see we're getting that P2017. So there's our P2017. And so DTC is active. Turn ignition on, scan tool, powertrain control module. With scan tool, actuate the SRV as SRV solenoid control state, which we did. Verify view TTCs. Is the status active for the DTC? Yes. So we're going to go to step 2. So short runner valve assembly. What they want us to do is turn the ignition off. And then we're going to connect a jumper between pins 4 and 2, which is between the sensor ground circuit and the SRV signal circuit and the short runner valve assembly harness connector. And then we're looking within the scan tool, if you remember, we're looking for that PWM feedback signal. It says it should be less than 3% with the jumper wire in place. And if it is less than 3%, then they want us to replace the short runner valve assembly in accordance with the service information. If it's not, then then they want us to go through and do some additional testing here. So what I'm going to do is kind of reach back there, turn the ignition off, reach back there, disconnect the intake, and I'm going to find an alligator clip that we can use as jumper wire on, and jumper pins 4 and 2, and run this next piece of troubleshooting they want us to run. Again, it's either going to be a bad SRV, a bad piece of the wiring harness somewhere, or it's going to end up being that this aftermarket intake, as well as the other aftermarket intake I just got in, isn't going to work. So they want us to do pins. Well, I've got you here before I let you go. Connector view up, pin 2 and 4. And 2 is the ground, 4 is the sense output. Yeah, sensor ground. And the SRV signal circuit. Yeah, okay. That's the control circuit. So yeah, we want to go between 2 and 4. So again, let me get that out of there, get an alligator clip set up, and I'll bring you right back. One moment. And welcome back. So I figured it would also be maybe a kind of worthwhile test as well, to test the actuator not installed into the intake, and just see if we can get it to display the same fault. So again, you can see that we're got you plugged back in, actuator only, no intake. We're going to go back into the scan tool. Cancel. Let's try that again. There we go. Found the vehicle. Go back into the PCM. Read fault codes, DTC. Alright, so let's clear them, because it looks like it still came up, but what I want to do is just clear the DTCs for now, and then we're going to actuate it. Yep, still present, which is fine. Okay, so it looks like it cleared the one for the actuator, which is fine, what we were looking for. Now let's actuate it and see if that fault code comes back. And I don't know if you heard that. I'll let you see the actuator. Now it does actuate it. Well, you saw that there. Now if we back out our actuation, let's go back and read our fault codes. There it is. It's back. So actuator, no intake, we get a fault. So we either definitely have a broken SRV actuator, or we got a problem with our wiring to that actuator. Now we know we're getting power because we can actuate it, and we know it turns because, again, we can start to actuate it. So if we look at our pinout
Fused relay output, we know we have that, because otherwise we wouldn't be able to control it. We know we have ground, because again, otherwise we wouldn't be able to control it. Now there's the SRV actuator control signal. We know we have a control signal because we can tell it to do something and it does it. The only thing we're not sure about is the sense output. In other words, is something wrong with the sense output on that where the PCM isn't receiving what it thinks it should receive. And that's what this test here is supposed to tell us when we short pins 2 and 4 together and see if this, like I said, it should be less than 3% with the jumper wire in place. So that's what I'm going to do next, is we're going to get that module off that wire, perform this test, and like it says, if it is less than 3%, then we definitely know that we've got a problem with the module. Now, is it possible that module just happened to die when we disassembled the intake and we had the intake sitting here kind of in a box for months on end? Yeah, it's possible. Anything's possible, especially with the module being 12 years old. Is it possible that it broke as a result of being installed into the newer intake? It's possible as well. So let's do this. Let me do that. Let me get that disconnected, get the jump wire in place, and I'll bring you right back. One moment. And welcome back. So I just want to show you something we saw while we were getting ready to pin this connector out, and hopefully you can see that. So 4-position connector. You'll see 2 of the pins are there. You can see them. They're flush with the end of the connector, but you can see pins 3 and 4 are not. They look to be pushed back inside of this connector where they're maybe not making good enough contact. And pins 3 and 4, looking at our pin out, is SRV actuator control signal and the sense output. Now, when we were actuating it, it looked like we were getting control signal because it was moving when we told it to move. But I don't like the fact that those pins are way back there within that connector. And as a matter of fact, you can kind of see that number 3 here is also starting to push back into the connector as well. So what I'm going to do, I'm going to disassemble this little piece here so we can get these pins out and just kind of give them an eyeball. It may just be that they've kind of been pushed back into this connector over the years, or it got pushed back in the connector inadvertently somehow when we want to reattach it. So we'll bring those pins forward and see if that fixes our issue. We'll also do our test here as well while we're at it. But let me do that first. Let me bring those pins forward, plug that module back in, and see if that takes care of our issue. So one moment. And welcome back. I'm going to try to get you in there to see this, but I think we found the issue. On these pins, 3 of the wires, the little locking tabs that you can see on the backs of the connectors there, hopefully. That little square are missing. So the little metal tabs that are supposed to lock those connectors in place inside that holder are missing. That would explain it. So they were able to slide out of the connector enough where we could actuate it, but it wasn't getting the signal back to the PCM to say that it had moved, which makes complete sense for what we're seeing here. So we're going to have to wait until we get a new connector on there. It should be hopefully moments for you. The new actuator that we purchased is actually a repair type kit where there's a TSB for 2009 Ram 1500s in which that rear wiring harness that connects to that servo or solenoid is too short. and it doesn't allow for enough engine vibration and movement. And what would happen was it would break those pins right at the terminal, kind of how those are broken, ironically enough. It would either break right at the pigtail, right at the connector, or break further down the harness because there wasn't enough slack. And the repair kit comes with a new connector and some pigtail wires. And what we can do is we can just use the connector that comes with the new actuator. And we may even just use the new actuator that comes in, to be honest with you, rather than reuse this one. I mean, I think this one will be fine once we get that connector connected up. So we'll just kind of have to think about whether or not we want to use this 12-year-old one or use a replacement. Now, to be fair, the only replacement one I could get was a Dorman one, but the Dorman one, like I said, did come with that repair harness, which will give us a new connector. So once that gets here, like I said, it'll be a little while for me, but it should be moments for you. What we'll do is we'll get in here and I obviously put that new connector on, and then we'll repeat our test, and hopefully that should get rid of our error message. So once that connector and that new part arrive, I'll bring you right back. So one moment. And welcome back. Well, as we discovered in the last clip, it seems there are issues that we thought were potentially related to how this intake handled the runner system. Looks to be not related to this. In fact, it was related to the connector that we showed in the last clip, where some of the retaining clips for the pins on the inside of the connector had broken and allowed the pins to push out of the connector. So this is the Dorman kit that we were talking about earlier. And what it comes with, obviously, is a new servo, as well as what we were just looking here, which is what they call this is an OE fix kit. And the reason why this is called an OE fix is that obviously you can see there's a new connector with a new pigtail on it. And what was happening was that there's actually a TSB for like the 2009 1500s and some other 2009 Chrysler vehicles, where there wasn't enough pigtail space given, as we were talking about earlier, going between the connector and the servo and the rear wiring harness. And with normal engine movement and vibration and such, and people just maybe taking on and off the intake, you know, the wiring would break here or further up the chain. And Chrysler's TSB actually has you put on a pigtail harness kind of similar to this, and basically find out where the wiring broke within the harness and splice in a longer pigtail to give it that freedom of movement. But since we know that we got some broken pins in our connector, we're going to use their OE kit and splice this into the existing harness. Now I'm going to probably leave, to be honest with you, a lot of this wiring on here and just kind of make like a really long pigtail for it. That way in the future, if we have to take this intake out of here, we can do it, and we got a little bit longer kind of pull that we can kind of pull it away from the firewall to get to this rear connector, because it's always a pain to get to that rear connector, even for the non-2009s that don't encompass that TSB, that do already have the longer pigtail like we do on this one. It's still kind of a pain to have to pull the intake out part way just to get to this connector and back. And, you know, like I said, we're just going to utilize this to give us a little bit longer of a pigtail. So they give you pigtail, they give you some covering, some loom, and they give you some crimp-on bits here, some crimp-on non-insulated terminals with some heat shrink. Well, that looks to be, kind of looks like normal heat shrink without the sealant in it, just by looking at it from here. So what I'm going to use, rather than those, and I'll put a link in the description, just a kit off Amazon. It's got some insulated butt connectors there, but these have they're marine grade, but they also have the adhesive lining in them. So as we heat them up and shrink them down, the glue will kind of squeeze out of them and help seal up our connections. And so yeah, because you're not going to miss much. It's just going to be me following that harness. And unfortunately, yes, you probably noticed they made them all the same color. So what you have to be mindful of is keep this connector oriented the same way you keep that connector oriented, and just splice the new wires in one at a time. That way you keep your pin orientation correct as far as, you know, what's power, what's ground, what's the servo control, and of course what's the return for that. So I'm going to get to work on this, and this is where it's a little bit of a pain because I have to kind of reach over the engine to get to everything. And if you notice in between the last clip and now, we did take the belt off and take the alternator out of here because it's a lot easier without the alternator because you're not having to reach over it as much. So I'm going to get started on this, get this spliced in here, and I'll bring you right back. One moment. And welcome back. So you can see we got our splices made and our heat shrink finished into our what is now our new connector. And I was just going over the color codes one more time. Looks like we've got everything in the right spot. And in case you need those pin numbers, let's see here. There's the printout of the connector breakout. So pin 1 is brown with gray, pin 2 black, pin 3 dark brown with a light green tracer. I'm sorry, dark blue with a light green tracer, and pin 4 is dark blue with a white tracer. And there's your descriptions there. So that's 1 through 4. That's right to left with the top of the connector facing you, as you see there. So now that we've got that complete, and we did trim a little bit off that pigtail. We took about, as you can see, that much off, but we left, you can see that much there. Now normally the connector would have stopped like right about here where the splices are. So we got about that much extra to play with. So what I'm going to do is coil a small piece of this up and just kind of zip tie it to itself just for support, because this anchor right here at the end you see me pointing to, that goes to the back of the intake, and that's what secures the wiring harness. So I'm going to put like probably a little bit of a loop on this just to help support where those splices have been made. And we're also going to, again, we'll put some zip ties on it. I'm also going to hit it with a little bit of fabric loom tape as well. Again, this is just in the event that we ever have to pull this out again. You can see we've got a lot more slack on that rear connector now, that once we get our MAF disconnected, you know, we can pretty much pull that intake almost completely out in order to get to that rear connector now, you know, which is quite nice. It's going to be a pretty cool change. So what I'm going to do next is just blow some compressed air in here. We've had our intakes covered up, as you can see there, and we were just being really, really careful during our splicing and our crimping procedures to make sure that we didn't drop any stray bits of wire anywhere. But I will take some compressed air and kind of blow through this channel once we're done, before we remove our covers for our intakes. And then I think what we'll do is we'll just get the intake sat in place, ready to be bolted back on, and we'll just make that one servo connection there in the back right there, and just use the scan tool like we did last time and do some testing on it. But in the meantime, what we can do while we're working on that is, if we take our replacement servo here, just to show you, it kind of behaves a lot like the factory servo did, in the sense that if we line this up with the pin that's in there, you can see we still have to kind of push down on this to get this to go. Now originally I thought that was going to be a problem, and again, I thought that was what was causing our issue with our codes, but come to find out it was just that faulty connector. Now, the other nice thing about the Dorman kit is that not only do they give you that piece and that new pigtail, and if you don't have the modification already done, I'll show you what else comes in this bag. Again, that little piece of wire loom, which we will use, we'll get that wrapped around that wiring. But along with the splices, the little metal splices, again, we just used some heat shrink ones that had the sealant of our own. They also give you this one, which is the new gasket for that rear piece there, which we will use because remember we had to reuse the one off the old factory intake. So we'll go ahead and take advantage of that while we're here. But they also give you this little stud piece in case you have one of the ones affected. And if you have a 2009 that's affected with the issue of the potential too short pigtail that could damage the harness, instead of having this stud here on this corner where that one clip you saw earlier would clip into, you would just have 3 standard bolts. And then part of the TSB is they have you remove this bolt and replace it with this stud and then clip the wire loom over it, which they also give you the zip tie that also fits over that stud inside this kit in case you need it. So that actually is I'd have to say, a pretty useful kit. Now, granted, we already had the modification because our setup already had the stud in this corner, so we're just going to go back with the hardware that we took out of it. But in case you need it, it's there. Like I said, we're going to use this. I'm going to go ahead and install the newer servo since we've got it. And like I said, we'll get it up in there and we'll just kind of set it down, ready to be kind of bolted in place, but we'll run through the scan tool testing first. And of course, we're going to go back with this intake since we know everything else about this intake works fine. And this intake, I'm not quite sure yet, because again, I bought it thinking it was this that was the issue. I might return this, or I might keep it for a spare. I'm not quite sure yet, but again, even though it's different manufacturers, it looks like it's the exact same molded unit. Again, even the colors of the seals that they gave you with this are the same ones, or the same color, I should say. With that being said, I'm going to get this servo installed in the back of here, neaten up the wiring, the pigtail wiring there a little bit on the intake, and get this thing sat in place. Once it's sat back in place, I'll bring you back and we'll go through some scan tool testing. But I'm just going to replace the seal, get the servo in here, and bring you back in a bit. One moment. And welcome back. So we got our intake just kind of loosely just kind of set in place right where it needs to bolt up. We did go ahead and connect up the MAF sensor since we were back there, as well as the SRV solenoid. So we're going to do like we did before. We're going to do a local diagnostic. We're still going to have a lot of error messages in here because we still have a lot of stuff disconnected. But what we want to do is actuate that SRV now. And man, we should have better behavior. Okay. Again, I'm just going to go straight into the PCM since that's kind of what we need. Read fault code, DTC information. All of this we're kind of expecting to happen, yep, because we have stuff disconnected, which is fine. What, getting your screen to wake up here, sorry. Sorry for the glare. Yeah, we know. Okay, yeah, I'm just going to toggle it to open. Ooh, I don't know if you heard that. Let's try that again. I'm going to toggle it and get you closer so you can hear it, but you can hear those louvers inside the intake moving now. Okay. Now, if we pull the data stream up, yes, we know we only have 10 selected at a time. Select those. We want our 2 SRVs. See, we got input. Aha, we have something different now. You can see that the short runner PWM feedback's at 78%. Last time it was at 100. There you go. Energize, open. 100%. Closed. De-energized, closed. Okay, beautiful. So now if we back up and read our fault codes again. Throttle, 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 electronic throttle, which we know about because we have the throttle body disconnected, intake and the generator. Okay, so that's just the alternator. Okay, beautiful. So as you can see there, we no longer have our fault codes for our SRV solenoid, which is good. Okay, let me turn this off and get the battery disconnected once again so I can get in there. And we still need to torque down the intake and then hook all this, get the alternator reinstalled, and of course hook all of our electrical back up. I've got one more thing I want to show you on this video. I was hoping the pressure sensor for the vacuum / boost would have got here, but it's delayed due to bad weather currently. But what I'm going to do is I'm going to work on getting this intake torqued back down again. It's 9 foot-pounds, in case you were wondering. And do I still have that sheet? Yes, I do. You probably saw this during the assembly video, but in case you want to see it again, that's your torque pattern. And the book's asking for 9 foot-pounds on those fasteners. Let's see. When we go to put the alternator back in, since it was previously installed once, just want to show you the little trick that I use. Since it's been installed, these little spacers on the back of the alternator kind of pull forward to pinch it into the bracket. Now you can put a C-clamp on there, and I've done that before, and kind of push on it. Kind of awkward to get it situated, but you can do it. Kind of push that spacer back out so you can slip it onto the bracket. And you can also do this. Now this happens to be a 27, I believe a 24 or 25 millimeter will also work. As long as it's a deep well and the bolt will fit through it. I've done this. Just don't go crazy and get an impact on here. Just a hand ratchet or a hand wrench would be fine. You can put the socket over the bolt like that, thread the bolt through, and as you tighten it, it should pull this spacer back out. And what you can do is you can just tip the alternator on its side and just watch. And once that spacer goes flush, or even just maybe a little bit more in than what it already is, that's all you really need, and you should be able to slip the alternator back in place. So let me work on this. Let me get this intake torque back down and get the alternator and such back in, and I'll bring you back. One moment. And welcome back. So we're just in the process of getting the intake torqued back down and all the electrical connections for fuel injectors and such taken care of. And now we're up to just putting the alternator back in. And I kind of wanted to show you what I was talking about earlier. So you can see the little bit of the sleeve that's kind of protruded out that helped pinch this onto the timing cover bracket. So all I'm going to do is going to put the socket and the bolt on, as I was kind of talking about earlier. Got you zoomed in, so I got to kind of move things around here a little bit so you can see. So I'm just threading this bolt backwards. Into its own fitting. and then we're gonna kind of push against this ear, and then the bolt should pull this way, pulling that spacer in. Like I said, you don't want to put too much torque in it on doing this because you don't want to break the ear off, but like I said, it's just a standard socket wrench. Seems to work just fine. And as we tighten this up, you should see this metal sleeve kind of pull itself in. And again, I'm not going very tight, not very much pressure, and there you go. We're now even with the inside of that ear. So we can just pull our bolt out. Take our socket off. And there we go. We're now ready to drop the alternator in. And now with those ears pulled out, it should drop in with pretty much zero effort. And with that being said, I'm going to get the alternator installed and bring you back. One moment. And welcome back. So we kind of got things buttoned up under the hood as far as putting the intake and everything back on. And again, you didn't miss anything. I've got all that as part of the build series when we did the initial build. But one of the other items, besides the SRV error, the broken sensor, which again is delayed. I think they're saying it'll be here maybe in the next 2 days or so at this point. But when we were kind of looking around things, I noticed that the brake light switch had been kind of pushed in a little bit. And by that I mean, here's the part number for the replacement. And the way these work is when you replace them, you clip them in, you push down on the brake pedal so the brake pedal doesn't touch the plunger here. And you twist them, you lock them into the bracket, and then you let the brake pedal go. And you'll hear this make a ratcheting type clicking sound. And basically that's it calibrating itself to this particular brake setup as far as the internals. So that way it knows when you step off of it, you know, you're releasing the plunger, the brake light will come on, and when you let go of the brake, the brake pedal will come back and push on the plunger, turning the brake lights off. And the only thing I can think what happened here is that since these get pushed in to calibrate, is that when we were taking the brake booster out and putting it back in, I must have inadvertently hit this and kind of pushed this plunger in further than what it was supposed to, because what was happening was the brake lever wasn't making contact with the plunger, and as long as the key was in the ignition, the brake lights were staying on. And I'll show you what I mean here. Let me pause you and get you in a position where you can see this, and I'll bring you back. One moment. And welcome back. So we're going to put the new brake light switch in, and I'll show you what happened to the old one. But the new one, you can see it's got a little, kind of like a tab right there. It's going to go in the center of this tab right here. But what we want to do first is push and get this brake pedal out of the way. And then once this is turned and locked in place, then we'll let the brake pedal go, and you'll hear it here. You'll hear it make a ratcheting type clicking sound as it calibrates to the distance of the brake pedal internally. Hopefully I'm going to knock you around a little bit. I apologize. I've got to get in here to do this. Okay, we're locked in. Now I'm going to let the brake pedal go. And you hear that ratcheting? Okay, that switch is now calibrated to this brake pedal distance. And we're just going to plug our connector back in. There we go. And now, yep, we're actuating the switch again. Okay, good deal. That should take care of that. I'm going to pull you out of here, and I'm going to show you what happened to the old switch. Again, sorry for the camera work. I've got to unclip you from the car mat. There we go. Okay, so this is the old one, and you can see what happened there. You can see that that's pushed pretty much all the way in. And what had happened, the only thing I can guess is when we were either removing or reinstalling the brake booster, I must have picked up on the brake pedal or hit this with my hand and kind of pushed this the rest of the way in, eating up the rest of that kind of internal calibration where this is, you know, again, you can see this is all the way to the bottom as it'll go, but that's too far in to make contact with the brake pedal. So kind of a minor thing, but again, we noticed it because the brake lights were constantly staying on as long as the keys were in ignition. So it's just another, you know, post first time startup issue to take care of. So let me clean up some mess here and I'll bring you right back. One moment. And welcome back. Well, I figured we'd finish this video up with doing another code scan now that everything's back together. Now that we've got our SRV solenoid or SRV valve / solenoid taken care of. We got our brake switch taken care of, which as you can see there, no brake light. And if we come in here now, brake light, you can see the reflection on the television. None. Okay, beautiful. So now we got brake lights again. Okay, so I figured we would come in here and just do a code scan. Yes, I know, you need windshield washer fluid. I haven't filled it yet. Okay, auto ID'd okay. And I'm just going to do a smart detection. So ABS is showing one code. Let's see what they are. Yeah, implausible data received from ECM, stored. Okay, so the only active code that we have at this point is a heated steering wheel, which that we already knew about. Everything else is in stored status. So this is awesome. And just to let's go into PCM. Let's enter the PCM. And let's do one more test on our SRV actuator. So if we do read data stream, SRV, give me those two values. And not what I wanted to do. Let's go into actuation test first. I'm in the wrong spot. I need to come here, SRV, and then go in the data stream from here. Yes, we know we can only do 10 at a time. Okay. There we go. That's what I'm looking for. So now if we say open, beautiful, energized, you see, we're getting that now. Closed. All right, perfect. Open. Energized, open, beautiful. And finally, one more time, closed. And we can back out now. And now we're going to go into read fault codes one more time. And no DTCs present in the PCM. Beautiful. Okay, that definitely took care of that issue. Yes, exit diagnostics. I'll take our key out of the ignition. I'll get the dongle on it later. Okay, awesome. So we've got a fix. We verified our fix. We got the brake lights taken care of. So the only lingering issue that we have is just that Banks 5 to 15, 0 to 15, sorry, PSI sensor, which again has got delayed due to weather. It's supposed to be here in the next couple of days. Everything's put back together. It's not missing any. It's not saying that it's missing any sensors. We got a little bit more. We got 2 more quarts of the braking oil that came in today. We're going to go ahead and put a little bit more oil in it just to kind of get it about halfway into the safe zone on the dipstick, but awesome. So as you saw, I jumped to a little bit of a conclusion on this one early, and I shouldn't have done that. And that was with that SRV. I thought for sure with the way that SRV solenoid or valve had to be kind of tweaked to get the bolts to line up, that was going to cause an issue. So when we had the fault, I thought for sure that was it. You know, there was something wrong with it being an aftermarket intake, you know, yada, yada, yada. And as we saw earlier in the video, when I was kind of taking apart the old SRV solenoid and kind of poking around it and running into the same issue, you saw when we began the troubleshooting steps in the documentation and went to put that jumper wire in, that's when we noticed that 3 of the 4 pins in that connector had their retaining tabs broken, and it was allowing the pin to push out of the connector, basically not making contact with that servo in the back of the intake. So we utilized the Dorman kit, and yes, you heard me say it right. We utilized the Dorman OE fix kit for that, not necessarily for that issue, but we utilized parts out of that kit to do a repair onto this one, to include also using their SRV actuator. We could have probably used the factory one, but considering I kind of took it apart and kind of tweaked around with it for a little bit, I'd rather not have to pull this intake back off of here again, but you know, time will tell. So, long story short, do your troubleshooting, verify your connections, verify your powers, verify your grounds before you condemn a piece of equipment, and that's unfortunately what I did here. Now, that being said, we got that intake in again because we thought we were dealing with an aftermarket intake design issue. Now, the good news is I got that from Amazon. We haven't used it. It's easy enough to put back in the box and return it. And it, like I said, looking at the color of the gaskets and everything that came with it, it looks like it's the exact same intake that we have. It's just being sold by multiple manufacturers online, but again, same product. And that's what you get with it. You get the intake, you get all the seals except for the rear one for that servo, and they give you a new bag of hardware. So with that being said, I will bring you back for the next one, and the next one will be where we replace that pressure sensor, and then we'll do a longer start and run time on the truck and verify that sensor that we're going to get in will fix that issue. And again, we're just going to continue to go through and verify that whether or not we need to continue to top off any fluids like coolant, power steering, transmission, so on and so forth. So with that being said, I've rambled on long enough. If you have subscribed already, I do thank you. If not, please consider doing so. I hope this video you found it useful, and stay tuned because as you well know, we've got a lot more to come on this truck yet, to include its first native voyage, getting it back driving on the city streets, and of course the rear gear changes in the differential, and quite a few other things that we got planned coming up. So with that being said, I will let you go, and I'll bring you back for the next one. Thank you much. Bye.